Hey guys, welcome back to my CCNA 200-301 course. Patrice is here, and in this video we are going to review wireless networks basics. Are you ready? Let's get started. I'm pretty much sure most of you have implemented wireless networks in one of its simplest formats at your home or at your small office, where you have an internet service provider which provides an internet connectivity through a device that we normally call it internet router or internet modem, depends on the solution you're using to connect to the internet. And this device obviously is able to use that solution and all of those standards to connect to the internet. And on the other side, it is also an access point or wireless access point. AP or access point or wireless access point or WAP are the two same things or same terminology we use for our WAPs. Our WAPs are basically the devices that provides wireless networks for us. So at a minimum, you need one access point or one WAP to provide wireless connectivity to your devices. So this device at your home or at your small office provides wireless connectivity to your wireless capable devices like your computers, your phones, your tablets, TVs, gaming stations, etc., to be able to connect to this router, and then from this router goes all the way back to the internet. Now we want to learn more about these wireless networks and see how they work. First of all, we have to dig a bit deeper in physics. Wireless networks use electromagnetic waves, which are form of energy, and they actually travels like this. So these are electromagnetic waves. They have different properties, so they can be described with different properties, but the most important one for us is how many of these waves can be transferred within 1 second, because this provides data transfer for us. More waves per second can provide more bits per second, so it can provide more bandwidth for connections. This number is called frequency. I mean, how many waves you can transfer within 1 second is called frequency. And it is measured by Hertz, which is named after Heinrich Hertz, which was a German physicist. And in short, we write it as capital H and small z. For example, if we can transfer 4 waves in 1 second, this is going to be 4 Hertz. And now technology evolves in a way that we can transfer billions of these waves per second. So we may have kilohertz, which is 1000 waves per second. We can have megahertz, which is 1 million waves per second. And we also have gigahertz, which is 1 billion waves per second. So the more, the main takeaway for you from here is the more hertz we have, the more bandwidth we will have. And we can actually transfer more and more data if it can reach to specific levels of frequency. The thing is, wireless networks, I mean computer wireless networks, are not the only wireless networks that are using electromagnetic waves. Like the radio you're using at home to listen to the music or listen to the news or whatever radio channel you're listening is also using electromagnetic waves. Police radio devices that can communicate to each other also using these electromagnetic waves. So each country has a regulatory department to actually determine which levels or which bands or which frequencies are free to use and which frequencies are belong to police, to the emergencies, or like to the military services, etc., etc. But two bands or two specific frequencies, and recently one more added, so now three, are free to use for computer wireless networks, so you don't need a license for it. The first one is 2.4 gigahertz, which was the initial band for wireless networks. And then we moved to 5 gigahertz wireless networks. And recently, very recently, in Wi-Fi 6 and 7, and obviously maybe after that, of course, we got to 6 gigahertz electromagnetic waves, so we can reach to very higher frequencies, so we can transfer more bandwidth. I'll show you in a minute that different standards that are using these bands to reach to a specific data transfer rates. The thing is, these are not only this specific frequency, there are a range of frequencies per one of these things. One of the CCNA exam topic is RF, or radio frequency. All of these waves are actually called radio frequency or RFs, but to be more specific, whatever between 3 kilohertz to 300 gigahertz is called an RF, or radio frequency. But as I mentioned before, there are a lot of different services that are using radio frequencies, and these are the ones that we are allowed to use them in our computer wireless networks. The available frequency bands that I spoke and told you they are available for computer wireless networks are not a single frequency. I mean, for example, for 2.4, it's not only 2.4, but it's a range of frequencies in that band. For 2.4, it is something between 2.4 to 2.4835. So as you can see, it's a range of frequencies that are available. To be able to manage this range, we divide this range into different channels. And for 2.4, since it's an old technology, the frequencies are having, the channels are having overlap. So for example, if you start from channel 1, the schema of the channels are like this. So we have this area that interferes between channel 1 and channel 2. So if one network use channel 1 and the other one use channel 2, then there would be some interference and we cannot take advantage of the whole channel or the whole available bandwidth we have. There would be some decrease in the performance. So for 2.4 gigahertz frequency band, we have only 3 non-overlapping channels, and they are channel 1, channel 6, and channel 11. So these 3 channels are non-overlapping channels for 2.4 gigahertz. If you are in a network that they still need to use 2.4, consider this: to use these 3 different channels to be able to avoid from interference as much as you can. But for 5 gigahertz and for 6 gigahertz, the technology has evolved. And for these 2 frequencies, the channels are non-overlapping, so they are like this. So they can benefit from the whole wave, and the performance of those networks obviously gonna be much better than 2.4 gigahertz networks. IEEE is responsible for wireless networks standards, and they defined 802.11 standards for wireless networks. The first introduced standard was 802.11, which used 2.4 gigahertz, and maximum it could provide 2 megabits per second. But over the years, as you can see in the slide, different standards have been defined. They use different frequencies, and they can provide more and more bandwidth as they evolve. And recently things have been changed. It's not depicted in this slide, but as I mentioned, Wi-Fi 6E and also Wi-Fi 7, which will be released very soon, is using actually 6 gigahertz frequency as well. And also a group of companies that manufacture wireless devices get together and they defined Wi-Fi Alliance. Like I think, if I'm not mistaken, in 2019 or 17 there were 800 companies, but now I don't have the number. But anyway, this logo you can see on this slide, this Wi-Fi, you may have seen it on many different devices, or at least on the boxes. This trademark means that that specific wireless device has been tested and also is being confirmed it is compatible with Wi-Fi standards or IEEE standards. Also, as you can see in the slide, there are some naming conventions for IEEE standards as well, like 802.11ac, also known as Wi-Fi 5, and AX is also known as Wi-Fi 6. Wi-Fi 6E also uses this standard number, but it uses 6 gigahertz band and it can provide much more bandwidth. And Wi-Fi 7 is the newest generation of this family, which is supposed to be released in 2024. If we flash back to the first slide that we spoke about it, the wireless access point you put in your home or at your office provides an area, and if any device goes to that area, goes to that coverage area, would be able to connect to that wireless network. Based on 802.11 terminology, this area is called BSS, or Basic Service Set. It is also called BSA, Basic Service Area, or a wireless cell. Anyway, whatever you call it, this is the area that you can connect through that wireless network. To be able to see that wireless network or other devices understand the existence of this VAP should advertise some information. One of this information is called BSSID, or Basic Service Set Identifier, which is basically the unique MAC address of the wireless access point. Yes, we had the MAC address for Ethernet connections, wired connection, and also we have MAC addresses for wireless networks. And this also needs to be unique on the wireless access point. The other information that is getting advertised by your VAP is called SSID, or sometimes we call it network name. You have seen this millions of times. Whenever you open your phone, for example, and you ask your phone to search the area and figure out what wireless networks are available here, the names you see on your phone is called SSID, or network names. And that name is getting advertised by the VAPs in that area. So you can figure out which SSID you want to connect, and then based on the security stuff that we will be speaking about them in the next video, you would be able to connect to that wireless network. This is good for small areas like your home or your office, small office, obviously. But if you have a 5-story building office, or you want to provide wireless connectivity in an airport, obviously one access point will not be enough. As soon as the devices go out of the range, they will not be able to connect to this wireless network anymore. So we have to put more VAPs in that area and extend our BSS. And this has to be done in a way that we have overlaps in the coverage area. First, let's see what we call this. This will be called ESS based on IEEE terminology, extended service set. You got this service set and you extended it through another WAP. So now it is ESS, and this has to have overlap because you have mobile users. So they are walking in the airport. So if this overlap does not exist, when they are moving from one access point to the other one, for example, this area, then they will be losing their connectivity and they have to connect to the other access point when they go to the coverage area. So you have to manage your access points in a way that can actually provide full coverage in that area. Alright guys, this was our today's video. In the next video, I'll be talking about Cisco wireless networks. I mean, we dig deeper with Cisco stuff. I wish you enjoyed today's video and see you in the next ones.